Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Static electric field and Coulomb's law. The electric charge is due to either deficiency or excess of electrons in the atom of the material. Static electric field is due to a charge at rest and be visualized as comprising of lines of forces or flux. Electric field is the space or region around the charge in which the effect of the charge is felt. Laws of electrostatics, like charges repel and unlike charges attracts, as well as Coulomb's versus square law. So this is the picture regarding like charges. Here we have taken two positive charges, both are repel. Like charges, this picture is of the positive charge and the negative charge. The charge from positive charge is going to the negative charge. And Coulomb's inverse square law is also known as Coulomb's law simply. Now Coulomb's law states that the force between the 2 point charges Q1 and Q2 in space is directly proportional to the product of the charges and inversely proportional to the square of the distance m. According to the Coulomb's law, force is proportional to the product of both the charges Q1 and Q2, and force is inversely proportional to the distance between the two charges represented by R. F is proportional to Q1 Q2 by R square. Then force F is equal to K Q1 Q2 by R2, where K is the proportionality constant, and that K equals to 1 by 4 pi epsilon, where this epsilon is the permittivity of the medium. Again, this epsilon divided into epsilon naught as well as epsilon r. Epsilon naught is the absolute permittivity and epsilon r is the relative permittivity. Force between the two charges is given by F equal to Q1 Q2 divided by 4 pi epsilon naught epsilon r square. Units for the force is newtons. Permittivity of the medium is epsilon. Formula is given by K multiplied by Q1 Q2 divided by 4 pi F r square. Then in terms of the units, the term K, the constant, so constant Q1 is coulombs, Q2 is also charges of, and 4 pi F is the force, so newtons, and r is the distance between the two charges Q1 Q2, so it is measured in the meters, so meter square. We are simplifying this, we are going to get square Newton meter and in meter. And coulombs square Newton meter is nothing but a farad per meter. So farads per meter, the unit for permittivity of the medium. Now permittivity of vacuum or free space is epsilon is equal to absolute permittivity epsilon naught, that equal to 8.854 into 10 to the power of minus 12 farad per meter. The force acting in vacuum or in free space, you are going to get F equal to 9 into 10 to the power of 9 Q1 Q2 by R square. Next, the relative permittivity. For air medium, it is approximately equal to 1 farads per meter, and for any other medium, epsilon r or relative permittivity is greater than 1. Vector form of Coulomb's law. So we have points Q1 and Q2. The distance between this Q1 and Q2 is r. Then Q1 is the distance of OR, that is represented by the position vector r bar, and Q2 is the distance of r2 bar, that is position vector of OQ2. Finding the distances, the distance between r1 to given by r2 minus r1 bar That is, an unit vector for those things, you can find it unit vector equal to R2 bar minus R1 bar divided by R2 bar minus R1 bar. So along the R1 bar, that is U bar is the unit vector, that is equal to R1 bar minus R2 bar divided by R1 bar minus R2 bar of modulus. Force on Q1 due to Q2 is F12 equal to Q1 Q2 4 pi epsilon naught epsilon R R12 whole square divided by the unit vector Q12, and force on Q2 due to the charge Q1 is 1, that equals to Q1 Q2 divided by 4 pi epsilon naught epsilon R R21 square multiplied by Q21 bar. A 2 millicoulombs positive charge is located in a vacuum at P1 and a minus 5 coulomb located at P2. Find the vector of force given data. The charge Q1 2 millicoulombs at P1 3 minus 2 minus 4 and Q2 is minus 5 microcoulombs at P2 1 minus 4 2. First find out position vector. Vectors R1 is equals to 3 ux minus 2 uy minus 4 uz. R2 equals to ux minus 4 uy plus 2 uz. R21 equals to R1 minus R2. So R1 minus R2, and this will be minus, plus and minus 2 ux plus 2 uy minus 6 uz. Magnitude of R21 is equals to square root of 2 square plus 2 square plus minus 6 whole square equals to square root of 4 plus 4 plus 36 square root of 44. Unit matrix U21 is equals to R21 divided by magnitude of R21. 2 root 11. 2 by 2 root 11 ax plus 2 divided by 2 root 11 uy minus 6 divided by 2 root 11 uz. Ax divided by root 11 plus uy divided by root 11 minus 3 uz by root 11. Now force on negative charge, that is Q2, F equals to Q1 Q2 divided by 2 pi epsilon naught r square, which equals to 9 into 10 to the power of 9 Q1 Q2 by r square. F equals to 2 millicoulombs multiplied by minus 5 microcoulombs divided by r is root of 44 whole square multiplied by 9 into 10 power minus 10 power 9. 10 power 9, 10 power 3, 10 power minus 6. 90 divided by 44. Force 90 divided by 44 multiplied by unit matrix, that equals to 90 divided by 44 multiplied by ax plus uy minus 3uz divided by root 11, 0.6167 ux plus 0.6167 uy minus 1.8502 uz. Magnitude of this force is equal to square root of 0.6167 whole square plus 0.6167 whole square plus minus 1.8502 whole square. This value, when you simplify, it will come square root of 4.1839, which equals to 2.04546 newtons. If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.